Okay, so this lesson is on simplifying square roots. So we're going to start super easy. Square roots of 25 and 16. These are perfect squares. I'm going to show you how to do these on your calculator. So to find square roots, you push the second button, then you push this x squared button. And we're going to type in 25. And you get 5. That is because if you did 5 times 5, you would get 25. Okay, that's what square roots are. What times what will give you what's underneath. So the square root of 16, again, if you're not sure, try and type it in. Square root 16 is 4. So the square root of 16, you would put 4. Square root of negative 81. Well, let's try that. Square root of negative 81. It tells you there's an error, okay, because it's a non-real answer. You cannot have a negative sign inside of the square root. So this is not a real number. You can't have the negative on the inside. Well, let's type in the second one, this negative, let me clear out of here, this negative, and then the square root of 49. And you get negative 7. So look at the difference between those two. There's some like this on your worksheet. If the negative is on the inside, it's not a real number. You cannot take the square root of a negative number. If the negative is on the outside of the square root, your answer is just going to be negative and then whatever the square root is. But again, if you're not sure about the rule, do your calculator. And if it tells you, like if you type this in, again, it's going to tell you, whoa, there's an error. It's not a real answer. It's not a real number. Okay? All right, let's do the square root of 28. Square root 28. It is a super long decimal. Let's change it, see if we can change it to a fraction. We cannot, so that means we actually have to do some math and we have to simplify this. So here's how you simplify square roots if it's not perfect. We're going to start with 28. And I always like to start by dividing by 2. Okay, so I'm going to do 28 divided by 2. And you get 14. We put our answer down on the bottom. We're going to keep trying to divide by 2. So let's see if we can divide by 2 again. 14 divided by 2. Whoops. Is 7. So when I divided by 2, I got 7. Hopefully you realize 2 will not go into 7, but in case you don't, let's keep trying to divide by 2. It does not work. So here's my simplification. And what your rule is, here we go. If it appears twice, you can put it on the outside. Okay, so like, see there's 2 2's. So if there's 2 2's, I'm going to put 1 on the outside. And if there's only one of something, like that 7, there's only 1, it goes on the inside. So the square root of 28 will reduce to 2 square root 7. Now you're probably super confused. Let's do another one. Let's do 75. So first, I guess, let's start back. I always like to check it and see, maybe it's a perfect square, and then I don't have to do all this craziness. It is not a perfect square. So I got to start my factoring. So let's try and divide by 2. Well, that didn't work out evenly. Let's try and divide by 3. That worked. So when I divided by 3, I got 25. All right, let's try and divide 25. 2 doesn't work. 3 doesn't work. 4 doesn't work. You see what I'm doing? I'm just going through all the numbers. Oh, look, 5 worked, right? So when I divided by 5, I got 5. So again, let's use our rules. If it appears twice, I can take it out on the outside. So there's 2 5's. So that goes on the outside. If it's only there once, it goes on the inside. So 3 goes on the inside. Let's do another one. 32, let's see. Square root of 32 is not a nice number. So we got to do our little chart. So let's do 32. Let's start by dividing by 2. 32 divided by 2. That gives me 16. Okay, that worked. So I'm going to put 16. Let's divide by 2 again. Whoops. So 16 divided by 2. Okay, that worked again. I got 8. So I would put a 2 and an 8. All right, let's divide again. 8 divided by 2 is 4. So I got a 2 and a 4. And let's divide again. Hopefully you know 2 goes into 4 two times. Okay, let's use our rules. If 2 is there twice, it goes on the outside. So those 2 black 2's that I marked out in black, pull out 1, 2. Okay, I'm going to mark, I got 2 more 2's, right? The 2 2's that I marked in blue, again, makes 1 go on the outside. And then what's left over is a 2, so that goes on the inside. Now, I pulled out 2 2's, right? These 2 2's gave me the black one, and these 2 2's gave me the blue one. If you pull more than one thing out, the rule is that you multiply them. So 2 times 2 is 4, and square root of 2 stays on the inside. Okay, let's do, I hope I got another one like that. Yes, all right. So -3 is on the outside. We don't really care about that. It's not going to affect anything. On the inside, I have 245. So first, let's see, square root of 245. Nope, that's not going to work. So let's do our little chart, 245. It ends in 5, so I already know 5 is going to go into it. So that's where I'm going to start. I'm not going to waste my time on the 2's. So 5 goes into this 49 times. Just by knowing my multiplication facts, I know 7 is what's going to go into that. If you weren't sure, you could have started with 2 and then 3 and then 4 and then 5 until you got up to 7. So 7 goes into that 7 times. So here, watch what I'm going to do now. I'm going to bring this -3 down, right? And then if it appears twice, I can take it out once. So there's 2 7's, so I can take that 7 out. And then what's going to be left on the inside is a 5. Now, these 2 numbers on the outside, remember you multiply them. -3 times 7 is -21. And then you still have square root of 5 on the inside. Okay, let's do another one. 252 is not a perfect square, just to save us some time. So let's see, I know 2 will go into 252. Let's see what that is. 252 divided by 2 is 126. And again, it's an even number, so I know 2 is going to work. Let's see what that is. 126 divided by 2 is 63. 63 divided by 2 does not work. Let's try 63 divided by 3. That works. I get 21. I know 3 will go into 21, right? I'll show you. And it goes in 7 times. Nothing goes into 7. All right, so here we go. Let's pull stuff on the outside. We're going to bring this 6 down. There's 2 2's, so that means I can take 1 2 out. There's 2 3's, so that means I can take a 3 out. And then there's a 7 left over, so it goes on the inside. So again, I want to multiply all of these on the outside. I want to do 6 times 2 times 3. So I get 36 on the outside and the square root of 7 on the inside. Okay, let's do letters. Letters, I love letters because I think they're easy, and hopefully you will too. Now, the first thing to know, the square root, there's something called an index, and it's a number out here. The very next lesson we're going to do, we're going to work with indexes that are not 2. But for most of these, we're going to work with 2. So if they don't put a number here, it's really a 2. So it's kind of like, you know, when we had an X, and it said they didn't put an exponent, we'd always put a 1 there. Or like if I'm talking about the whole number, they don't put the whole number of a 1 on the front. Same concept. They're not going to put the index out here. They're just going to expect you to know that if it's a square root, it's going to be a 2 out there. So the way exponents with variables work is you just say, how many times will this index go into the exponent? So how many times will 2 go into 4? Well, if you don't know that, then divide them. 4 divided by 2 is 2. So this would be x to the second. Okay, let's do another one. Again, this is a 2. So x's, let's do the x's. How many times will 2 go into 10? Well, if you're not sure, divide them. 10 divided by 2 is 5. So I would take out an x to the 5th. How many times does 2 go into 8? Well, if you're not sure, divide them. 8 divided by 2 is 4. So that would be x to the 5th and y to the 4th. Okay, again, this is a 2. How many times will 2 go into 17? If you're not sure, divide them. It goes in 8 times, so it would be x to the 8th. Now, it only goes in 16 times, right? 2 times 8 is 16. So there's actually one left over. So we're going to leave that one left over on the inside. Let's do another one. Okay, this one gives you the index of a 3. So it works the exact same way, only now we're dealing with a 3. So how many times will 3 go into 16? Well, if you're not sure, let's do 16 divided by 3. We get 5, so that would be x to the 5th. I'm going to leave a little bit of space. Let's figure out how many x's are left over. If I do 3 times 5, I get 15. But there were 16 x's, so that means there's 1 left. How many times will 3 go into 9? Well, if you're not sure, divide. 9 divided by 3 is 3, and it's nice and even, so that goes on the outside, and there are no y's left over. So it's x to the 5th, y to the 3rd, and then left in the cubed root is an x. All right, let's do this. How many times will 4 go into 8? It goes in twice. How many times will 4 go into 10? Again, it goes in twice, but inside my 4th root, 4 times 2 is 8, but I had 10 b's. So if I had 10 and I'm taking 8 out, then that's going to leave me 2 on the inside. Okay, let's do these. A lot of times I like to always start with fractions just by typing it in, because sometimes your calculator will do all the work for you and you don't have to do anything. So let's see. All right, it typed it in. Let's see if it'll change it to a fraction. It will not, so this one I actually have to do some work. If you have a fraction underneath the square root, we split it up. So I'd put a square root of 5 on top and a square root of 25 on bottom. Now let's see if either of these are perfect squares. So if I did the square root of 5, that's not perfect. That gives me a nasty decimal. If I did the square root of 25, I get a 5. So let's reduce this. Square root of 5 did not reduce, but on bottom it did. The square root of 25 was 5. And as long as you do not have a square root in the denominator, then you are fine. Okay, we are done. That is our answer. Okay, again, I always like to start these by just typing in the entire fraction and hope sometimes we get lucky and the calculator reduces it. So let's see. Yay! Okay, this is one where the calculator reduced it. Our answer is 2/9. Now let me show you how they actually got that. Again, remember you split it up in the square root of 4 over the square root of 81. And if you are not sure, if you did the square root of 4, it is 2. And if you did the square root of 81, it is 9. So that's where we got 2 over 9. Okay, square root of 5/3. Again, I always like to just start by typing it in. Sometimes we get lucky and it gives us our answer. This one does not. So let's split it up. Square root of 5 over square root of 3. Okay, let's see if either of those are perfect squares. Square root of 5 is not. Square root of 3 is not. So we got to get rid of this square root in the denominator. That's not allowed. So the way we do it is we're going to multiply by the square root of 3 on top and on bottom. Whatever's in your denominator, multiply by it on the top and the bottom. So on top, 5 times 3, I get 15. On the bottom, 3 times 3, I get 9. But now, here's why I did that. Because the square root of 9, that is a perfect square. The square root of 9 is 3. So that's how you take care of it if you get a square root in the denominator. Let me show you another example of one. So I'll just go ahead and tell you, you could type these in and they'd both be decimals. Neither of them turn out perfect. So we would multiply by the square root of 5 over the square root of 5. So on top, we get the square root of 30. On bottom, we get the square root of 25. Well, that's perfect. The square root of 25 is 5, right? So there's my bottom. 30 so the square root of 30 just comes on over. And that's your answer. All right, let's try and just type this in, see if we get lucky. Square root of 4 over 28. Nope, we did not get lucky, so let's split it up. Square root of 4 over the square root of 28. Well, the square root of 4 is just Well, okay, so I got another easier way. See, these are hard because there's lots of different ways. So let's do this way. Let's just reduce 4 over 28. So that'll reduce to 1/7. That's going to make my life a little bit easier. So I got the square root of 1/7. So again, I'm going to split it up. I'm going to do square root of 1 over square root of 7. Let's see. Square root of 1 is a perfect square. That's going to be 1. Square root of 7 is not a perfect square. So just like we did on the last one, we multiply by the square root of 7 over the square root of 7. So on top, 1 times anything is itself. So square root of 7. 7 times 7 is 49. And the square root of 49 is just 7. Now, maybe some of you have seen a pattern. If I have the same number on bottom, that is just your answer at the end. See, look at this one. Add square root of 3 times square root of 3. That answer is just 3. Square root of 5 times square root of 5 is just 5. So I'm going to start skipping this middle step for the rest of them. All right, let's try this one. Square root of 27 over square root of 48. Let's divide those, see if it works. Square root 27 over 48. Oh, look at that. We got one that just did it nicely for us. And it is 3/4. Square root of 27 over square root of 48 is just 3/4. All right, let's see if this one is nice for us. Square root 64 over 100. Oh, look, it's another nice one. It's just 4/5. And that's it. So if you will go try the worksheet and let me know if you need help.